What's going on today? I am doing excellent. It's sunny and beautiful outside. What are we working on? 2017 Mazda CX-5 with a 2.5 liter. There's our engine code, VIN 62,000 on it. Okay. And the complaint on this one is that it died. Oh, let's see here. What did they state? I'm not going to show you that. Died on road, long crank, and started. Engine light is on now. Okay? So I haven't even looked at anything yet. So let me get all my info in here and then we'll turn her back on. Okay, it's all entered. Now we're going to do a code scan. Before I start the vehicle or anything, I'm going to do a complete pre-scan. Let's see what codes we get. Oh, fuel pressure sensor, circuit low input. Interesting. All right, so the code scan's done. That P0192 is a fuel rail pressure sensor, circuit low. Okay, bank 1. All of our monitors have ran. So let's start it. No, actually what we could do before we get too crazy, let's go into engine. Data display. Fuel trim O2 sensor data? Sure. Let's take a look at this real quick. Yeah, I don't think it's going to be in this one. Let's try the other one. What was it? Fuel system data? Fuel pressure sensor data pit in there. Fuel pressure desired. Yeah, let's customize this before I start it. So we'll grab coolant temp, fuel level percentage, fuel pressure desired, fuel pressure sensor voltage, fuel pressure sensor PSI, fuel pump duty cycle, fuel rail pressure A, fuel rail pressure commanded, fuel system status. So fuel rail pressure sensor A, PSI 939 PSI, fuel rail pressure A commanded 985, fuel pressure sensor PSI 939, fuel pump duty cycle is at 56%, fuel pressure sensor voltage 1.43. This is key on, engine off, right? Or button on, engine off, whatever you want to call it. 939. So it looks like we just got repeat PIDs there. 89 degrees on our coolant temp. Open loop drive, and we're at 18% fuel. Okay, so we're a little low on fuel. Let's try starting it. Oh, fired right up. Got an exhaust leak. So it looks like we're getting the desired and the actual are matching. Oh, there she just went into closed loop. Okay, so fuel rail pressure A PSI is 400 and what is that? About 400 PSI. It's bouncing. Okay. 434 is our commanded. Looks like we're having a little trouble getting to that. And looks like these are just repeat PIDs. Okay. So it died on the road. So now the question is, you know, circuit low on our pressure sensor, did it, you know, if this pressure sensor circuit drives low, you know, what's the effect gonna be? Oh, there she just died. Look at that. 33 PSI. We might have a low pump problem. Oh, there's that long. Oh, now it definitely, yeah, long crank time. 13 PSI. So either we got a high pump problem or we got a low pump problem. I guess one thing to note here is you can see our fuel rail pressure sensor A is at 13 PSI, okay? Now, I'm gonna crank it. Pay attention to the fuel pump duty cycle. 95%, look at that. And we got 13 psi at our rail pressure sensor. Okay, now I'm not sure, but obviously I don't think the pressure sensor's lying. Okay, so that tells us a lot. That tells us that it's commanding that low side pump on 95%, and we're getting nada. Let me turn this key on. Where is our fuel level? Oh, pretty damn close to E. All right, and it said on the level sensor that we were at 18%. So, all right, so let me. We're gonna have to put a fuel gauge on this. There's no way around it. We gotta confirm that this is in fact. I mean, I'm already suspicious of the low side pump, given the symptoms. That is not a waiter, Paul. But you'll be waiting on me. Oh, really? I want one of those. All right, so looks like here's our supply, our low side supply line to the high pump, because this is our high pressure fuel pump right here. And then here's our low side supply line. So we can tap in right here, and we can adapt in and then get a manual gauge on this just to see what we're getting. And then, yeah, we're gonna be done here. I think we're gonna need a pump. I suppose we could try to current ramp it, check powers and grounds to it and whatnot, but I'm thinking we got a low side pump issue, or they ran it out of fuel and that level sensor's reading inaccurate. One of the two. So let me go grab my fuel pressure set. All right, change of pace here. Let's take a look. I got this Mazda in here in ProDemand, and all I want to do is I just want to see what my labor time is going to be for diagnosis. So let's go to estimate guide real quick. Let's go engine mechanical fuel system. So it says here fuel pump testing. Looks like they're giving you about 0.8 hours. We'll bill an hour. It's pretty standard. So and the reason we're going to bill an hour is because we're going to actually check the powers and grounds. Now, I've already lifted up the seat, the back seat here. It looks like they give you an access panel for the pump. That's what it's looking like to me anyways, which is awesome, Mazda. That is our fuel pump control module right there. So we'll lift this, we'll get this panel up. Let me show you how I did that real quick, just for learning purposes. So I went into service manual, and I went down to engine mechanical fuel system, clicked on that. Yeah, fuel pump unit removal and installation. Okay. Yep, so there's our access panel. And then it tells you, you know, rear seat cushion removal. There's just two little locks right there to lift the back seat up, okay? Don't get any easier than that. And you're right there. Quick look at the wiring diagram, just to give you guys an idea of what I'm gonna do here for testing. It's not gonna take us long, okay? But I wanna test it, just to be 100%. Engine performance on the 2.5. So pretty straightforward system. Come down here. We're gonna find our fuel pump module, or our fuel pump unit in the tank. And you can see there's our sending unit, and that goes up to the instrument cluster, and then here's our fuel pump. And now the power and the ground are controlled by the fuel pump control module right here, okay? And they're saying it's in the center front of the luggage compartment. Well, that is our fuel pump module, okay? You can see the wiring comes off and goes right to here. Anyways, we've got a fuel delivery negative, fuel delivery positive coming from our module. Okay, so that the module itself is going to duty cycle the pump, and it's going to control the ground and the power side. Okay, it's going to be a pulse width modulated pump. Now, when we were cranking it, the duty command, this this fuel pump command, FPC here, this yellow wire, if we follow that, yellow to 11, next diagram. Same thing with that diag wire, 11 yellow to 9, next diagram. Going quick here, guys. 9, you can see right here, fuel pump pulse width modulation, right from none other than our PCM, okay? Now that other purple wire is the fuel pump diag wire. Now that must be a command, a feedback to the PCM from the module for diagnostic purposes. Obviously they're calling it diag. I would imagine that's what it's for, and that's probably what tells it, you know, what's going on or whatever. You know, if there's an issue or whatnot. But what we can do is we can scope into these two, the negative and the positive. We can check them, look at the pulse width modulation just to show you what it looks like, and then we can wrap an amp clamp around one of these wires and get an amperage measurement on it when we're cranking it at a 95 with a 95% fuel pump with a 95% command from the module. Because if we're doing like a 56%, the amperage is going to vary, okay, and the pump speed's going to vary. So let me go into my scan tool. I'm going to turn the key on. Hold on a second. I lost communication because I turned my key off. So you can see we're in the engine, right? We don't want to be in here, I don't believe. So let's check real quick. Functional tests. Let's see if it gives us fuel pump. Yes, it does, right here. So that right there is going to give us the capability to turn this fuel pump on. Now I don't know if it's going to be 100% command. You know, there it's on, there it's off, okay? So let's go in, let's see something once. And that can be a variable because you got to be careful when you're doing current ramps on them when they're duty cycled like that. Let's see if they give us fuel pump module. I doubt they're going to because it's not on the network. You know, it's not on the network. So that computer is controlling that pump. Now I don't know, again, I don't know if I turn it on, is it going to be 100% duty command? I don't know. In either case, we know that when we were cranking it, that computer was, according to the scan tool, was commanding it at 95%. So that should be pretty good. If we do a crank, we'll just get an assistant and then we'll get our capture, okay? So let me get this up. Looks like we got Phillips head screws here. I'm gonna get this up and we'll get access to the pump. All right, so I've got the cover off. Now, the wires we're concerned about are the blue and the green. And it looks like our green is fuel pump negative and blue is fuel pump positive. So if we take a look here, but I don't get any easier than that. So there's our green and our blue on the right there. I'm gonna back probe in there. Let me get the probe. I'm just gonna set the scope up, okay? If we're gonna do a current ramp on this, we're gonna have to unwrap this a bit so we can get access to those wires. So let me do that, and then I'll explain the setup. All right, real quick rundown of how I've got this set up, okay? Our green trace here, all right? I've got it pierced into the green wire, which is our negative side of the pump, and then our yellow trace is pierced into the blue wire, which is the positive side of the pump motor, okay? Coming from the module. Our amp clamp is wrapped around the blue. It doesn't really matter, it can be either or. And we're gonna turn it on to low amp 20 mode, okay? Up here, yellow's in yellow, green's in green. So trace 1, 2, okay? So pump, what did I say that was? Yeah, this is gonna be pump. The yellow is going to be pump positive and the green is going to be pump negative, and then this is our amp clamp and our blue trace, okay? And then we have one ground coming from our yellow, and then everything's stacked. So all our grounds are stacked, okay? We don't put them in there like this. We use that extra one on the yellow and we stack them like this, okay? So we've got our amp clamp, green trace, yellow trace, all stacked. And then it comes in on the yellow there for our ground. For our other side on the yellow, because Snap-on scopes, you only need to ground your yellow and your green, right? Because the other two are already grounded internal to the scope. But here's our, this is the ground, okay? And this is going to battery negative. The reason I'm going to I had to put an extension on it. The reason I'm going right to battery negative is because I'm going right back to the source, okay? Now I could do, you know, use the power probe adapter in the cigarette lighter, but I don't know. I've been going to battery negative more and more because I just don't like the, you know, if that's the source, that's where I'm going, okay? Let's set this up. So to do this test, we're gonna go into our lab scope here. I'm going down here because there's less of a glare and it is humid today. Let's go into lab scope, 4-channel lab scope. Okay. All right, let's bring this up. Okay, let's turn all our traces. Well, we'll turn it on all 3 traces here. We got to change this to, they're all going to be in test lead volts DC. Okay, now our yellow, we're going to set it a 20 volt scale. That's our positive to the pump. Our green is also on a 20 volt scale because that's our I don't want to slow. Do I have a trigger on? I do. Let me turn that off. Setup trigger. None. We don't need a trigger. Okay. I suppose I could put a filter on all of them just to keep it clean. So 20 volt scale for positive and negative, okay? For our amp clamp, all right, so this pump will probably draw, I don't know, what does a pump draw? 10, I'd say 10 amps at the most. So 100 millivolts per amp and the low amp 20. So 10 amps is going to be what? That'd be 10 amps is going to be 1 volt, right? Let's put it in a 2 volt scale because that's going to give us a 2 volt scale is going to give us the capability to see that amperage. Let's see how many amps would that be? There's 100 millivolts per, so 100 millivolts, so that's 10, that'd be 20 amps. So 20 amps in a 2 volt scale, okay? Hopefully that makes sense. We're on a 5 millisecond screen. That should be more than enough time. I might even be able to crank this myself and capture it, so let's try that. I guess we better zero our amp clamp just to make sure here, and that's the blue trace again. We'll shut it off, we'll turn it on. Hit our 0 button a few times. I might have to invert it, I don't know. Really don't matter. Okay. Let's try cranking her once. Hopefully I can capture it. Now I'm pretty sure. There we go. All right. Oh, come on, stop. Hopefully we got it. We did not get it. Go ahead and crank it. Okay. What are we drawing for amps there? That pump is drawing about 2 amps. And for voltage, is my connector, my OBD connector in?
Yeah, it's on the ground.
Oh, put her back in there. Plug her back in. We got to get some data out of this thing. So are they varying the voltage? Whoa.
Hey.
Be honking the horn. People are going to think we're doing something weird out here. Especially when I'm leaning out the door like this. All they see is my legs. All right, you got her back in there?
Yeah.
All right, we're just gonna leave that on there because I don't want to have to recapture it. Let's see here. Let's go back in here. Maybe. Oh wait, no, home. Someday I'm gonna learn how to use my scan tool.
I feel like that's a good skill to have.
You know?
I buy a scan tool for 30 grand.
30 grand?
Better know how to use it.
Let's see, we need to go in fuel system data. I could put this in split screen mode, then I could look at both if I'd learn how to use this thing. Where the heck is it? Fuel pump, duty command, duty cycle, 56%. Oh, I don't believe you. Let me, oh, goodness gracious, come on. Duty cycle fuel pump. Where are you? There it is. Fuel pump duty cycle. I want to see if this is... Alright. Go ahead and crank that thing again. 95%. So at 95%... Yeah, it's at 95% the whole time. Okay. You can stop. Oh, that battery's getting low. We're at 11.2 volts. No wonder. That's why my voltage is low. I can't even deal with it. So, why are we only getting... It's because battery voltage is low. Damn it, I don't want to put a tender on this. Hold on. Alright, crank her again. Yeah, that battery's about ready to die.
Yeah.
Hold on. Alright, round 15. We got a jump pack on her. Oh, whoa, whoa, whoa. Whoa, whoa, whoa. Jumping the gun. Alright, go for it. Crank, 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 crank. There, now our battery voltage is up there. Beautiful. Okay. You're good, you're good, you're good. Settle down. Look at that. That's a nice ramp. That's a nice current capture. So what do we got there? We are pulling around 2 amps on this pump. Put some cursors on.
Hey, can I have this?
What are you taking? The jump pack?
Yeah.
Yeah, you can take it.
You're good. Yeah? You're good. Okay.
10.74 volts. 10.86, but we're at a 95% duty cycle, so at 100 it would probably be 12. So we got 1, 2, 3, 4, 5, 6, 7, 8. Right there. 7.2 milliseconds in our delta. Yeah, so let's do the math on that. You got your phone on you?
No.
Son of a... Just remember that. 7.2 milliseconds. I can figure out my pump speed later. And we were pulling 10.73, 10.76 volts. About 2 amps. Okay. Let's try one more thing. Turn the key to on, but don't start it.
That's where it's been.
Data. Of course, I lost my spot because the stupid scan tool. Yeah, this thing needs a battery. Freaking ridiculous. Oh my gosh. Wait, I don't even want to be in here. You sure you got the key on?
You talking about the noise?
Turn the ignition switch to on.
It is.
Hit it one more time.
I did. Now it's on.
Yeah, okay.
It's like the LMTV whine.
We're gonna command this on. I have no idea what it's gonna do. Okay. Ooh, I can hear it.
That's the radio, silly.
Stop. Zoom. That's probably 100% command from that computer. Sure is, because now we're getting 11 point. Yeah, that's what it does. So the functional. Okay. All right. I don't need your help anymore. I got her figured out, kind of.
All right.
Thanks.
Off?
Yeah, you can. Yeah, you can shut it off. Hey, thanks a lot. So, let's see here. Let's come out a little bit. That is our ramp. So, what are we getting for a speed there? That's 100%. That's got to be 100% duty command. So to see the pulse with modulation, we're gonna have to put the pump in and get this thing running. So I know it needs a pump. Still haven't checked fuel pressure, but given what I'm looking at here, 1, 2, 3, 4, 5, 6, 7, 8.
Plugging it back in.
1. Oh, thank you. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 right there. 8 segments. 6.68. So because I'll just leave this on here and we'll get a pump here and hell yeah. Okay. I don't know, do we check fuel pressure? I mean, what's the point? Obviously it's not pushing any fuel pressure. It's only pulling 2 amps. I don't doubt my fuel pressure sensor at all. This is 100% a bad pump. And you can hear it and it sounds weak. And given they only have 18% in their fuel tank, I imagine this thing's been ran low a few times. Not accusing, just saying. And this pump's probably been burned up. So we're gonna leave these piercing probes on here. Obviously we'll have to clean this up and we'll put the pump in and then we'll get after captures, okay? Hold on, before we get carried away. So I've got the 5 amp test light hooked into this fuel pump circuit, okay? We're gonna test this. So obviously the negative end of the test light is hooked to the negative side of the pump. Positive side's hooked into the positive side, okay? 5 amp test light. It's commanded on the scan tool here. And there you go. So if you were worried about powers and grounds, don't be, because it can carry 5 amps just fine. Needs a pump, guys.